Unveiling the ocean's goldmine, infinite fuel reserves for millions of years. Imagine this: beneath the vast, unexplored depths of our oceans lies a hidden treasure trove of fuel that could power humanity for millions of years. The ocean, covering 71% of our planet, remains one of the most enigmatic and least explored regions on Earth. While we've sent ships and treasures to the ocean floor, a recent discovery has unveiled something far more valuable: an enormous goldmine of fuel reserves hidden beneath the waves. But here's where it gets controversial. This discovery comes at a time when the world is fervently focused on combating climate change through renewable energy sources. Ironically, the ocean, a seemingly endless body of water, holds a vast, untapped reservoir of renewable energy just waiting to be harnessed. For decades, companies have been eyeing the ocean's waves and tides as potential energy sources. However, the ocean's true potential lies in its abundant hydrogen, a clean and powerful fuel. And this is the part most people miss. The challenge has always been extracting this hydrogen without producing harmful byproducts. Seawater electrolysis, the most straightforward method, also generates toxic chlorine gas, making it impractical for large-scale use. Currently, hydrogen production relies on fresh water, a resource increasingly scarce due to climate change. Enter Equatic and the U.S. Department of Energy's Advanced Research Projects Agency Energy, ARPA-E, who might just have the solution to our energy woes. Equatic's innovative technology taps into the ocean's hydrogen reserves without the toxic byproducts. Their breakthrough involves creating electrodes with finely architectured catalysts that don't react with seawater's salt, ensuring the stability of chlorine. These oxygen-selective anodes, OSAs, produce oxygen and hydrogen safely, paving the way for large-scale hydrogen production. But here's the kicker: these OSAs are not only efficient but also environmentally friendly. They are recyclable and recoated with catalysts made from abundant earth elements, avoiding the need for rare earth metals. The process also addresses another critical issue: carbon removal. Equatic's dual-purpose technology captures CO2 from the air and traps it in solid minerals, making it a game-changer in the fight against climate change. The first field tests are set to begin at a Singapore test plant and a Quebec commercial plant, with plans to remove 109,500 tons of CO2 and produce 3,600 tons of clean hydrogen by 2026. Equatic's COO, Edward Sanders, highlights the global implications of this breakthrough, stating that it removes the major barriers to carbon removal and clean energy production, such as high cost and the need for specific geological formations. This innovation could revolutionize the renewable energy sector, providing a clean and abundant source of fuel. But what do you think? Could this be the key to a sustainable future, or are there hidden dangers we haven't considered? Share your thoughts in the comments and let's spark a debate on the future of energy. Underground hydrogen revolution: 200 million tons of clean energy buried beneath us. A glimmer of hope for humanity hidden beneath our feet, a 200 million-ton energy reservoir ready to sustain us for millennia. When we discuss clean energy, we often follow a familiar narrative: solar, wind, batteries, and more recently, hydrogen. However, the challenge lies in the fact that most hydrogen production methods are costly, energy-intensive, and, ironically, contribute to carbon emissions. Despite significant technological advancements, we persist in looking skyward for solutions: solar panels on rooftops and wind turbines spinning in the breeze. But what if we've been searching in the wrong place all along? What if the most promising energy source is actually lying just beneath our feet? We've been gazing upwards for solutions, but perhaps the future of energy is hidden below us. Let's face it, when we envision the future of energy, our thoughts immediately drift to the skies. We picture solar panels sprawling across rooftops and wind turbines punctuating the landscape. It feels like a race to harness the energy that falls from above. But what if we told you that the key to transforming our energy landscape is, quite literally, underground? This revelation comes from an international team of scientists who have made a groundbreaking discovery that is capturing attention and investment. Deep within a chromite mine in Albania, a spring emerges, not of water but of hydrogen. Almost pure hydrogen, in fact. Estimates suggest that over 200 tons of hydrogen are released annually from this site, marking it as the largest natural hydrogen flow ever recorded on Earth. the hidden spring, the gas leak, and the quiet energy revolution. This finding is not merely an intriguing geological curiosity, it represents a significant milestone in energy production. For the first time, we have tangible evidence that underground reservoirs of natural hydrogen, similar to the discovery of 300,000 liters of hydrogen in a small American town, may be accessible and potentially commercially viable. This is a true game changer. Hydrogen has long been hailed as the fuel of the future. The catch? Its production has traditionally been expensive, energy-draining, and carbon-releasing. However, this situation is different. Here, the hydrogen is already present, concentrated, and ready for use, eliminating the need for electrolysis or methane combustion. This is not just theoretical. Drilling at the Goldmine mine has shown that when specific geological fault zones are reached, hydrogen is released at precise locations. This natural system has been functioning for millennia and is now being understood for the first time. But before we get too excited, we must consider the delicate biosphere and the slow geological processes at play. While the enthusiasm surrounding this discovery is warranted, it's essential to approach it with caution. First, geological hydrogen is not a short-term renewable resource. It can take millions of years to form what can be extracted in just a few years. Second, these deep geological zones are home to unique life forms that thrive in complete darkness, relying on hydrogen as their energy source. Disturbing these systems without careful consideration could lead to the destruction of ecosystems that we have yet to fully comprehend. Moreover, while 200 tons per year may seem significant, it pales in comparison to the 100 million tons of hydrogen produced globally each year. However, the real significance lies not in the quantity but in the geological model itself. For the first time, scientists have successfully mapped and simulated the formation of an underground reservoir of natural hydrogen. This discovery shifts the narrative. It compels us to consider that the Earth, in its overlooked depths, may hold a natural, clean, and more accessible energy solution than we ever imagined. At the same time, it calls for prudence. The excitement surrounding hydrogen must not lead us to repeat the mistakes made in oil extraction, where environmental assessments and ethical considerations were often overlooked. Perhaps we can integrate this discovery with the 45,000 tons of green hydrogen produced annually from Europe's underwater energy initiatives. Ancient hydrogen reservoirs, the future of clean energy. Hidden beneath our well-known landscapes are vast, unexplored caverns filled with a gas that has the potential to transform the energy supply landscape. While much of the focus has been on renewable sources like wind turbines and solar farms, a lesser-known resource is beginning to capture the attention of investors. The idea that hydrogen could become a cornerstone of a sustainable future has sparked significant discussion. However, many current strategies rely on the process of splitting molecules using renewable electricity. An intriguing alternative is gaining traction: the extraction of hydrogen that has been trapped in rock formations for millions of years. Recent research indicates that these underground reservoirs, once regarded merely as geological oddities, may surpass traditional reserves in both volume and accessibility. Initial field studies have uncovered natural hydrogen concentrations in various geological settings, including peridotite-hosted systems, crystalline basements, and sedimentary basins. Unlike traditional hydrocarbons, this hydrogen is continuously generated through interactions between water and rock, particularly through the transformation of iron-rich minerals. This ongoing production process supports the notion that these reservoirs can replenish over geological timescales, providing a flow profile that resembles renewable energy sources more than it does the diminishing oil or gas wells. For investors, the appeal lies not only in the reliability of supply but also in the potential for lower production costs, which are based on straightforward drilling and separation methods rather than the expensive electrolysis typically associated with hydrogen production. Among the trailblazers exploring this new frontier, a select group of pioneers is honing their methods to locate and assess these elusive hydrogen pockets. Techniques such as seismic imaging, airborne magnetics, and downhole geochemistry are being employed to map potential areas, while pilot wells are being drilled to evaluate flow rates and purity. Early findings have shown encouraging results, with some aquifers yielding hydrogen at rates exceeding several hundred cubic meters per day, with minimal or no greenhouse gas emissions. For long-term investors, these indicators suggest not only a low emission profile but also a promising pathway to profitable margins. The geographical diversity of these hydrogen sources further bolsters their potential. From the cratonic shields of Africa and Canada to sedimentary platforms across Europe and Asia, promising targets appear to be widespread. This is in stark contrast to the regional concentration of metals like nickel or lithium, which often face geopolitical and environmental challenges in their supply chains. The emerging map of natural hydrogen supply indicates a more balanced distribution, potentially shielding investment portfolios from risks associated with reliance on a single jurisdiction. The technology involved in harnessing this resource is relatively uncomplicated. Once drilling is completed, the gas is directed through separation units to remove moisture and impurities, resulting in hydrogen that meets pipeline standards. Existing gas treatment facilities can be modified for this purpose, which helps to minimize capital expenditures. Additionally, as the energy grid adapts to accommodate variable renewable inputs, these wells can act as a stable midstream component, helping to mitigate intermittency and enhance grid reliability. For those monitoring trends in energy transition, it is essential to keep an eye on the evolving regulatory landscape and the advancements in drilling techniques that could improve yield predictions. Even slight increases in flow rates can significantly influence the economic viability of hydrogen, given its importance in transportation, industry, and power generation. Furthermore, forming alliances among technology providers, drilling contractors, and off-takers will be crucial in creating a cohesive value chain that connects the subsurface resources to the pipeline infrastructure. Thor Energy plc, LON-THR, stands out as a prominent exploration company dedicated to natural hydrogen and helium, boasting a substantial presence in the highly promising South Australian region.